Hello everyone. This video we're going to be looking at arithmetic series where there is no last term. So we're only given the first few terms and we got to find the sum of, say, the first 200 terms or something like that. So this question is going to look like this. Not like that, we did that one already. It's going to look like this. We're going to have an arithmetic series, which means that we're adding the same number each time, or subtracting, I might add. Right? Add the same thing each time, subtract the same number each time. Still arithmetic. Okay, but we'll stick with the adding and leave the, maybe we'll do a minus in a bit. So now, what we got is a series that looks like this. We have 3, 7, plus 11, 15, and it goes on. And the question is, well, we said 200. It's getting big, might hurt the brain. Let's try it. Some of the first 200 terms. All right, so how do we do this one? Well, we're going to list the numbers that we know along the side as usual. But importantly, there's going to be a different style of formula to use. And maybe I'll show you where it comes from and then what it is. So basically, from before, we had, that is from the sequence section, we found that we could find the value of a term by using this formula here. And then the first video about series, arithmetic series, was like this. Sn is n over 2 t1 plus tn. Right. Well, this version, remember, was used when there was a last term available. Okay, but in this case, there isn't. So what we do is a little substitution, because you can see the tn there, well, is also there. So what we're going to do is we're going to replace this tn with all of this. Since all of this is the same as tn, we're just switching it out. So that's going to look like this to begin with. T1 plus the new stuff now. Alright, so that's going to be now T1 plus n minus 1 times d. See? This part here is just Tn. But now we do some algebra, make it look good. What you always do is collect like terms. We got a T1 there and a T1 there. They're the same, so they can combine together. And so that gives the version of formula that we're going to use now for this section, or for this situation. That is, if we need the sum and we don't have a last term, right? We're going to use this instead. So let's take a look. Let's work it out. I'm going to rewrite the formula that we just worked so hard to get. N minus 1 times d. And then just in here, so it's all near the top, and I got some real estate to work out the question. This is what we need, or this is what we're given. And we need, the first 200 terms. Okay, let's check it out. So for the usual, I'm going to write down the values that we know. We have T1, the first term, That is, the value in the first location is 3. The common difference, I think you and I can both see what it is, but let's just show it. 7 minus 3. Take one term, subtract the term in front of it. Right? So you get 4 for that. And we are given that we want the sum up to the 200th term. That is the 200th spot on the series. Okay, so the 200th slot there. And I think that's it. T1, yep. N, yep. D, yep. N's a couple of times. So it goes. What are we looking for? 200 terms. So here we go, good people. That's like this. So I'm just now going to take it from the formula we have here. Replacing n creates 200 over 2. 2 times t1. 200 minus 1. Oh, whoops. T1. Oh, we'll get it next time around. And then the D is 4. Okay, we'll simplify this a little bit. That's 100 on the outside. I'm going to show it even though we could do it all together. All right, and then was 4 times 199? Too weird. So I'm going to go 4 times 200, which is 800. And then minus 4. Distribution, right? One of those. Just multiply and distribute those brackets, or distribute the 4 in to remove the brackets. So we're getting closer. We got 100 times 6, or 100 times 6 plus 796 there. Then I think I'll do the same trick. We add these together and what do we get? We get 100 times, that's going to be 802. Now remember, the nice thing about multiplying by hundreds is just put some zeros on. So it's going to be 802 with 2 extra zeros there. And that, good people, is the sum of the first 200 terms of this arithmetic sequence, starting at the value of 3 with a common difference of 4. All right, hope you enjoyed that. Here's another one. Oh yeah, let's do a subtraction one. Because I said adding and subtracting, they count the same with this topic. So let's make a series where we subtract the same thing each time. And I do want to highlight. This is still arithmetic series. We're going to add up all the values that we get. So, well, let's just do something like this. 100, then plus 98, plus 96. Now, you might think it's going to stop down at 0, but keep in mind, we can go past 0 and keep going, right? This is dropping down by 2, so we know the common difference is minus 2. So this will get down to 2, then 0. Then it'll be plus negative 2, right? And plus negative 4. A little awkward when it's written like this, but it can keep going. So let's say, just for fun, that we want to know what the sum of, we'll do 200 terms. Just looking at this and looking at things cancel out, try and figure it out ahead of time. I think I know what it is. Well, let's do the calculation for sure. And if you want to punch in 200 terms, no, more than that. 200 different numbers with 2 and 3 digits in each. Forget it. It's like 600 buttons. Don't want to do it. I'm going to do it this way. First term, 100. The common difference, watch this. Okay, you take a term and you subtract the number in front of it. So this guarantees that we get the correct value. Okay, I say this because adding and subtracting stuff, don't want to get them mixed up. Okay, so we got the question at the top this time. T1, D, I think we need N. Oh yeah, secretly given to us in an obvious spot there. All right, so N's 200 again. The situation is no Tn, right? No last term. So, never fail, or not to worry at least. We got the other version of this formula. To use. All right, so we're going to have S 200, 200 over 2. Oh, look at this. So I put A in the formula, and it's T1 over there. That shouldn't be happening. It's either one or the other. And I point that out because math is sometimes, math and computer science start intermingling, start mixing. And if you start mixing variables like this in your program, man, struggles. Life will not be good. All right, so keep it consistent. And notice, it's all lined up, all looking good. Let's keep it that way. So 2 times the first term, 100. You know how to do that, just add some zeros. The n minus 1, I'm not going to write it as 199, I'm going to keep it like this. And do the distribution trick. Now D, this requires some attention, all right? Put it in a set of brackets, otherwise it's going to look like 200 minus 1 minus 2. Which isn't right. It needs to be multiplied, so have the brackets around the minus 2. No brackets, we're not going to get along. Okay, so make sure the brackets are in there. Doing some simplifying, 2 divided by 2, 1. 2 times 1, 2. And then the distribution there for those two terms. So minus times the plus is a minus, and then it's going to be, so minus 400. I guess we'll put in brackets just to keep it looking good. And this is going to be plus 2 when that goes in there. And watching all the brackets, again, for your computer program in the future, boy, those have to match as well. Okay, so just to check, got the outside right. 200, we multiplied that into the first term, we get 400 of the negative variety, and we get 2 of the positive variety. So there's no more multiplying, everything's just added, subtracted, combined together there. All right, what does that leave us with? That leaves us with minus 200 plus 2. I know it's minus 198, but that's actually not so bad because we got 100 here. Just put the zeros on. So we got minus 100, I'll show it. Minus 198, 2 zeros. Again, bring this down as well. Don't leave the reader wondering what 19800 is. All right, so what is it though? This is the sum of the first 200 terms of this particular series. All right, so the I guess note it's a big negative because we only have 1, 2, 3. I guess those are 50 positive values. That means there'll be 150 negative values, or 149 because there's a 0 there, I guess. Something like that. All right, that helps check the answer at the end. All right, so hopefully you found that these two examples useful. We will conclude it there. Feel free to come back and join me for the next time.